The title of my presentation is Automated Approaches to Determining Chicken Eggs Perimeters Based on Their Digital Images. Optical digital control methods and ovoscopy are used in the quality control of chicken eggs. Chicken eggs are investigated in the egg tester ovoscope. Egg tester can be of different designs. An easy-to-use installation of photographing chicken eggs under controlled conditions need to be developed. This research aimed to developing an automated method for determining the geometric dimensions and volume of chicken eggs by processing their images. To conduct this research, an installation was developed, which features a box consisting of the upper one and lower second parts. During the experiment, chicken eggs were placed on stand 6 in the middle of the chamber. Side walls of the upper and lower parts of the chamber are painted black from inside. Opening 3 with a diameter of 90 millimeters, through which the camera takes photo of the specimen, is located on the cover of the upper part. The opening is also painted black from inside. On the inside of the top cover, LED models are located around the opening, which are covered by a light diffusing screen made from white acrylic plastic. At the bottom of the lower part of the chamber too, there is the same number of LED models as on the upper one. The pictures are showing the structure of the chamber. The illumination flux emitted by LEDs located both on the upper and lower parts of the chamber can be adjusted by changing the voltage from two separated power sources. Figure shows the output voltage of which can vary in the range of 5-12 volts owing to the surface illumination of the specimen studies in the chamber can also vary in the range of 100-600 lux. In the source of research, the following parameters were measured. Constant voltage of the LEDs located on the upper and lower parts of the chamber. Illumination of the specimen surface. Chicken eggs were photographed at illumination E of 660 lux. The geometric dimension of studies objects were calculated automatically using the developed algorithms and the mechanical digital caliper, which an accuracy of 0.01 millimeters. A robust image processing algorithms can identify eggs in varying lighting conditions, orientation, and background complexes. The algorithm used in this work is based on classical image processing technique and consists of several major stages: images filtering, image segmentation using thresholds, macroscopical operations, erosions and dilations, object detections and calculation of detected objects' dimensions, high Y volume. Laboratory obtained RGB images of eggs are shown on figure. The initial step is the egg detection process involves images filtering, which aims to reduce the noise and smooth on the images while preserving the essential features like edges and contours of the eggs. A Gaussian filter is applied to the PlaceCare images to remove high-frequency noise. This filter blurs the images, which helps in reducing small artifacts that might be misclassified as spots. After preparation stage, images is segmented. Segmentation is an essential step where the goal is to distinguish the eggs foreground from the background. After segmentation, the binary images may still contain noise, holes, or fragmented egg shapes. To address these, macroscopical operations are applied to clean and consolidate the detected region. In the final binary images, where white pixels represent the object's eggs and black pixels represent the background, the areas of the object can be computed by counting the numbers of white pixels. These physical attributes of eggs are essential for various applications ranging from optimization incubation practices to prediction quality and ensuring customer satisfaction. Thus, this study is concentrated on computing geometrical perimeters of X, specifically their dimensions and volume. Table 1 summarizing X measurements and allows to compute the results made by proposed images recognition methods with manual measurements. It makes possible to estimate the effectiveness of the developed algorithm. In general, the data summarizes in Table 1 testing for the effectiveness of the developed automated algorithm for detection of the geometric perimeters of X. The obtained relative errors for height and width are quite low, which indicates that the method's accuracy is acceptable. A relative error is determining the volume was somewhat larger. This may be due to a more complex algorithm used in the calculation of the volume based on a two-dimensional images. An automated method for determining the geometrical dimension, height, width, and volume of chicken eggs based on processing the digital optical images is developed and tested. A specialized installation for obtaining photo images under controlled lighting conditions and an algorithm for calculation of X perimeters are proposed. The research results show a high consistency between the geometric parameters and X determining using the developed automated method and the results of the direct mechanical measurements. The relative error is in determining the height and width and volume of X didn't exceed 3 and 6% respectively. This indicates the effectiveness and acceptable accuracy of the proposed approach for practical implication in quality control system. The results show that the developed installation and images processing algorithms have the potential to create easy-to-use and reproducible system for automated determining the X parameters. This can help increase the productivity of sorting, calibrating, and quality control processes in the poultry industry.